what I'm writing in the collab, right? So Google Colab is a free service to write the Python code. So you have to type the code in that case. But yeah, you'll be able to see the same thing, right? So you can go to collab.research.google.com, right? So I'm using my local Jupyter notebook, but yeah, this is where you can actually start with, right? In case you want to code everyone, right? So I'm going to share it. So in case you are not used to with Python, so this is where you can start with, right? So I have not shared you this notebook because I'm going to be writing the whole code in front of you, right? But yeah, on Collab you can write a new Python notebook. You can start with a new notebook and you can write the code as well in case. Right. So let's go further. So yeah, we're going to be looking at the idea of blueprint of what are we going to, how should you approach any standard data analytics project. So join, yes, I think recording of this session is going to be shared. You should be able to access. You will have to connect to your point of contact at the company Technical Ventures, and I think that should help you out to hit the link with you. So here we go, everyone, and let's look at the idea of the blueprint of any standard data analytics project, how it should be structured, right, and how it should, how should we approach it. So we're going to be splitting this into simple 5 steps, right? So 5 steps to take to work with any data analytics project, right? So that's what we're going to be looking at. So what are the 5 steps? The step number 1, the super important step, right? The step number 1 is the step number 1 is the idea of we call it as domain exploration. So whenever the first step you should do is you should explore the business domain as much as you can, right? So you should go ahead and understand the business, right? Understand the business structure, how does it works, and understand the different business processes, how does it function and all, right? So this is the super important thing. Okay, and so that's one thing. Just a second. Yeah. So first step is domain exploration, where let's say if I'm working with banking organization, bank says that you want to perform data analytics on why customers are not buying credit cards or why they are not buying insurance. So first I need to understand the business of insurance. How does it work? All right. So and why the issues, the business resolve the issue. So the very first step is you should spend time on understanding the business process. Right? So how does the process happen? For example, in case of in this case, you want to understand why usually the machines get damaged, or what the business do when the machines get damaged. Do they sell it out, or do they scrap it, right? Or what are the common other challenges that they face? If the machine is not damaged, some other small issues, how do they handle it, right? So you do want to understand for what purpose they use the machine, what kind of production they do, how many hours they use daily. So these are common understanding that you want to collect before working with this project, right? So this is when you don't start with programming. You don't have to start with data. You have to just go to the business, people who actually work on the floor, work in the industry, talk to them, understand the process, ask them questions, relevant questions, and pen down all the answers, right? The common understanding, because you have to start on the top of, as a data analyst, you have to first become equivalent to any employee in that company, and then you have to start on the top of their mindset, right? So wherever they finish, that should be a starting point. So you have to first reach to their finishing point, right? So understanding the business process, understanding the common challenges business usually face and how they handle or tackle it. Right? Identifying few business beliefs. Right. So business might say that usually machines, when we don't use it for 3 days, it doesn't work well, right? So every business may have some beliefs, right? Some belief which they consider as a universal truth, or maybe consider as a business pattern. Some beliefs. Every business process will have some beliefs. For example, okay, if the customer is coming from this area, he will not buy credit card. These are common beliefs in the banking business, right? Or if the customer is having age less than 25, he will or she will not buy credit card. So that could be a common business belief. If the machine is bought in the month of February to March, the machine will get damaged. That could be a common business belief, right? So identify. Sometimes those beliefs have a pattern, a business pattern. Sometimes they are just not useful beliefs. So identify all business beliefs, possible reasons, because later you want to perform data analytics and verify these beliefs, right? So these are common challenges that you actually bring, questions, tasks that you actually bring from the floor of the business, where the business is actually functioning and they're actually using that product. This is the very first step as an analyst we should start with. The second step as an analyst is, the second step of any data analytics project is data collection and data exploration. Right? So this is the second step you should deal with, which is so this is where now once you are done with the first step, you start collecting data, because once you do the first step, domain exploration, you know exactly what data do you need. You might want to ask to different stakeholders of the business to provide you a set of data, right? Different units of the business as well. In some cases, you may have to also collect data from outside the business, which could be some common sources, social media possibly, or possibly the general, let's say, weather data from any particular website, or maybe the World Bank data, the economic crisis data possibly, right? Or maybe the government policies in manufacturing that might also impact the purchase of machines, right? Or maybe the quality of machines as well, right? So these are different challenges or maybe extra data that you want to collect, and then you want to do an exploration on that data, which is where you want to identify. So collect data from inside and outside business if needed. It's not always necessary that you need outside business data. In some cases, you have to identify that. It's your call to take, right? And then explore data and collect common popular issues with data. So with your experience of data analytics, you will gather that what are the common challenges with data, and you want to simply you want to simply collect those common challenges or common issues, and which you want to later very deeply verify them, or you can say very deeply explore them out. Right. So that's the second step. The third step is data cleaning, right? So data cleaning, which is where what we do is, so now every data may have a lot of challenges. It might have some missing values, some duplicate entries, and you have to handle them. So what you do here is you have to handle duplicate entries, handle missing values, handle outliers, exceptional cases, or maybe some unnatural values, right? So these are the exceptional cases that you want to handle them, right? These are the steps that you don't take on cleaning. And the fourth step is super important step, where we actually perform analytics, right? And that's the super important step that we should take care of, and that is exploratory data analytics, right? So this is where you start actually doing data analytics. There are two ways to perform analytics. One, using visualization, and two, using statistics, right? So using, or you can say EDA, using data visualization. As part of that, we perform, let's say, univariate analytics, bivariate analytics, and multivariate analytics. And next step, sorry, so this is one of the methods, which is using visualization. The other method is also to perform ADA using statistics, right? So that's another method to perform ADA using statistics. As part of that ways we perform, let's say we use a lot of statistical methods, which could be correlation analysis, which could be hypothesis testing, a lot of them. And finally, creating report, right, of conclusions, suggestions, and red alerts. Right. So from all the steps taken, we identified different conclusions, few red alerts possibly, and few suggestions. Red alerts are just immediate actions that they should take or they should be worried about. So yeah, this is the journey of any standard data analytics project. The 5-step journey that you can think of this as a template that you don't want to perform on any data analytics project, and we'll be also using the same template for our project as well. These are the steps that we'll be following. These are the steps that we'll be implementing in this data analytics project. So I hope you are good with this. I'm super excited about doing this, right? And going through this with you. Let me know in case you have a question if you want, right? Meanwhile, we have a question. We can see the certificate as well when we any type of software or any applications published as well as expired in computer. Is that right? Well, it depends. I mean, what kind of commands are we using, and insert ngr msc. Okay, that could be one of them, right? That could be one of them, Jisan, right? So it's a, I guess, a Visual Basic command, right? And it should lead to that. Okay. So, but I think that's a very different thing from what we're discussing at the moment. Okay. So I hope, are we all good, everyone, with this part? And so yeah, let me know in case you have any question with the current part of the blueprint for any standard data analytics project. Any question or you have? Are we all good? We'll go further. Right. So let's move further now. We're going to be going further, and this way we're going to be starting first with the very first step, which is the domain. The first step we are not going to doing that. We're going to start with the second step, which is like data exploration. We already loaded the data, so here we go. Yeah. So if you don't have enough data, Hiba, in that case, a way to handle outlier is to consider the outlier itself as a missing value, and then substitute it with impute it with a mean, median, or mode. Right. So that is going to be in case you have large volume of data. So you don't have large volume, and you don't want to remove the outlier. You don't want to drop it because that might lead to right. So if you want to handle such situations, this is one of the ways. You treat the outlier as a missing value, and then you take the action that you usually take on missing values. Okay, that's the idea. Right. So here we go. So here we go and start with it. So we already loaded the data, right? As you already know that we already loaded the data. We have PDF, which is right. So the data set that we have. So we're going to start with the step, which is step 2 called data exploration. And we'll be done collection here. So as part of exploration, we identify some common challenges. So we look at df.head again, right? So these are the columns that we have. So I hope we are now good with the meaning of each and every column in general. What is lifetime, what is broken, what is pressure, what is moisture, what is temperature, what is team, what is provider, right? As we can see that we do not have any identifier of each machine, right? So we don't have something called machine ID, or we don't have any machine number, or maybe machine chassis number, or maybe machine purchase number, anything like that, or order ID possibly, right? Or machine, the date of purchase of machine possibly, or date of deployment of machine. We don't have any such identifier of the machine, right? We just have only the quantitative and qualitative information a little bit about that. Right. So in head, you kind of see the structure, understand the structure while looking at df.head. Head simply shows you top 5 rows of the data frame, and it simply you understand each and every column, see the structure of data. The one thing you do is df.info. Info gives you the overall information about data. That says that we have data around 1000 entries, which is starting from 0 to 999. Definitely data cleaning is a big challenge. We're going to be actually dealing with that, right? So we may have such some issues. So yep, we have 0 to 999, right? So these are the 10,000 1,000 entries that we have. So we have around 1,000 values of lifetime. The data type is int64, broken int64, float, integer, float. These are different data types. Well, for 2 attributes, we have the data types as object. For pressure and temperature, you can see that it is not 1,000. So there are a few missing values in temperature and pressure that you would want to further explore at the point of data cleaning, right? So you can say one of the analysis we identify over here is data has some missing values. Right, so we are not exactly counting or cleaning them at the moment. This is just the exploration, right? The rest of the columns are quantitative, like int, float, but these are qualitative. Object means they have string. These are qualitative. You would want to further explore them, right? So team and provider. As you can already see, these are just team and provider are string. So team and provider columns are in string format. Right. So we have total 54 KB of memory, or you can say a space it's taking in the RAM. So for team and provider, we want to further explore that. So we can say tf.team.unique and tf.provider dot unique. So we have in team we have 3 values, like team A and team B and team C. These are the 3 different teams which are operating all the 1,000 machines. They have 4 providers, provider 4, provider 1, provider 2, provider 3, and like that. So these are provider 1, 2, 3, 4 providers, which are these are the people who, or these are the vendors or manufacturer possibly, who provide machines to the factory. Right? So that sort of information we have, right? So in data exploration stage, you just explore the common things or common issues, or maybe common structure or noteworthy points about the data, right? So we identified that these are the 4 manufacturers or vendors who are providing machines to the factory. Right. This is what we do as the second step, with the point of data exploration. Next, similarly, we can check his df.describe. Please repeat our point, right? So good questions. So it describes gives a statistical summary of the data, right? So it gives simply the statistical summary of each attribute, which includes the lifetime, there are 1,000 values. The average lifetime of all machines is 55 months, right? So all the machines are on an average useful up to 55 months, and the standard deviation is 26. The mean is the minimum value, that means the minimum number of months any machine is having is 1. All right, and 34 is the you can say 25% of machines are less than 34 months having, they're having lifetime as less than 34 months. half of the machines are less than 60 months and half of the machines are more than 60 months. That means half of the machines are purchased 5 years back, and you can say in purchased are more than 5 years old, and half of the machines are less than 5 years old. 75% of the machines are less than 80 months older. 25% of machines are more than 80 months older. Maximum age of machine is 93. That means the maximum machine lifetime of machine is 93 months, right? Which is around, let's say, 7 to 8 years. In between. Broken is a categorical attribute, right? So only the mean makes sense here, 39. That shows that out of all 1,000 machines, 397 machines are damaged, right? Which is like 39.70 machines. 39.70% of all the machines are damaged, right? Are broken, which could be a big concern for the enterprise. Pressure index. The average pressure on which machine was operating, average moisture, and average temperature on which machine was operating. 75% of the machines were operating for pressure less than 112. Yeah, we can find that how many machines are in the max lifetime, right? So how many machines are having ages 93? We'll see that exploration as part of exploratory analytics. We'll explore that. So 112, 75% of the machines are operating for pressure less than 112, and maximum pressure on which machine operates is 112. Moisture, 75% of the machines are operating for less than 113, but the highest or maximum moisture is 1156, which is quite huge difference. You see here, there's a huge difference between 75% versus max. There's a huge difference in that. Right, that shows that there may be few outliers in the moisture. Temperature as is proper, 113 and 172, you can say it's almost proper. Okay, so that's one idea about it. Have a look at this, right? So we can say we can have a doubt here at the moment that looks like the moisture attribute may have an outlier, an exceptional case, right? A very high value, 1156. 1 or 2 or possibly 3 outliers, or maybe 10 outliers as well, right? Yeah, so we can see that we have few possibilities of the outliers in this case of moisture, and that's one of the analysis that we kind of do here, or sort of identify here. One of the challenge with the data that we identified here. Okay, so now let's move further about that, right? So data exploration is more of identifying some common issues or common challenges with data, which later you'd want to investigate into that to assess that why it happened possibly. Right? So that's about exploration. That's about common exploration. Now we'll move to the third step, which is about data cleaning. We'll move about third step, which is about data cleaning. So first we'll check with we'll check for duplicate entries. Do we have any duplicate entries? For that we'll say df.duplicated dot sum. So we do not have any duplicate rows in data. That means the whole row is duplicated. That means the lifetime, temperature, pressure, broken of the machine, everything is same. That we don't have. The team manufacturer is same, so they don't have any such machine, or the set of machines which have the you can say common values of the attribute, or they are having almost all the same values. We don't have any duplicated rows or any duplicated entries here, right? So that way our data is good, right? We don't have to deal with duplicate entries here, right? So otherwise we would want to drop them. Next, check for missing values. As you already know, we may have few we identified earlier, right? So df.isNull dot sum, right? So we can look at here that we have 4 values missing in pressure and 3 values missing in temperature, right? So we have 4 values missing in pressure and total 7 values missing we have. and so that's where we have you'd want to deal with them. One of the way to deal with missing values is you want to drop those rows wherever there's a missing value. That's one of the ways to deal with it. But that may not be always the right approach, because when there's a missing value in one column, right? So there are 7 columns. If one of the column has missing value, but rest 6 are real values. So for the sake of one missing value, you may not want to lose the 6 real values, right? So that's where instead of dropping the missing values, you may want to impute or substitute the missing value with a statistical aggregated value. That could be mean or median or mode of that particular column, right? So we go to the idea here. We would not want to drop those rows where we have missing values. Rather, maybe we would want to fill in the missing values by some statistical value, which could be mean or median or mode of the data. So let's do that here. Now to identify whether to substitute it mean, median or mode, how do you decide that? So how do you decide whether what action to take? How do you decide that? Whether should I fill in the missing values by mean, median or mode, right? So there are a set of guidelines to do that, right? So guidelines to handle missing values, right? So the guideline is, if the data is categorical, you look at if it is nominal, the good representative of data is mode, so replace it by mode. If it is ordinal, median. In our case, temperature and pressure both are numeric, not categorical. If the data is numeric, right? So if data is numeric, right? It is not categorical, rather it is numeric. In that case, the suggestion is to check skewness, right? Check skewness, and or you can say that the suggestion is check skewness, and if it is skewed distribution, then median with the left or right. If it is normal distribution, then mean, right? Or in normal distribution, median is also closer to median as well, so you can also think of replacing it with median by default. So these are the guidelines, in order to check skewness. If the skewness is between minus 0.1 to plus 0.1, then you can say it is more of normal distribution, almost normal distribution. Else we call it skewed distribution. Okay, so that's the idea. So these are the guidelines that you want to possibly use to check the, how do you do the cleaning of missing values. Right. So in our case, we'll check the skewness, right? So let's data, we're going to do that here. Okay, so we'll say that df dot, we are missing values in pressure and temperature. As we can see that for temperature, it is closer to 0. It is less than, it is between 0.1 to minus 0.1 to plus 0.1. Whereas for pressure, it is just above that. It is not very much above plus 0.1, it is slightly above that. You can still think pressure as well also as a normal distribution, but temperature is very much normal distribution. Pressure is close to normal distribution. If you want to strictly follow that rule, then in case of pressure, you don't want to impute the missing values by median. In case of temperature, you don't want to include it by mean. Right? Otherwise, in both the cases, you can use mean as well. As in case of pressure, also it is not very much skewed. It's very much closer to normal distribution. Whereas temperature is almost normal distribution. Skewness shows the pickiness of the data, how much data is peaked up, right? So that's what information skewness represents. and you can say whether mean is a good representative of data, whether median is good representative of data, that can be interpreted from skewness. Right. To help you better understand skewness, maybe I can give an example. That could be sure, Omkar, I think you should be able to drop an email to the support team or maybe the team with which you are in point of, who is your point of contact, and maybe they should be able to help you out with that. So I think my whiteboard, I hope all of you can see my whiteboard screen, everyone. Right, so we understanding the meaning of skewness in general.
So how to do it?
What? I didn't.
Asking the recordings to the support team.
Yeah. So it is being recorded. You can connect to the team. Let's say you would have received an email regarding this webinar. You can just reply to them and they'll share you the link.
Okay. Thank you.
So for students, this question: do we need to have expertise in statistics before working on any data science project? Need not to have very core expertise at initial level. You should have idea of applied statistics, right? So when I say applied statistics, let's say you need to understand what is variance, what is standard deviation. You need not to remember the formula of variance and standard deviation. So when you say expertise is more on academic level, right? So you don't need the academic expertise. You need more of applied statistics understanding, right? So rather than remembering the formula of any particular statistical method, you need to understand when to use it and what sense does it make, right? So in explaining the skewness, I'm not going to show you the formula of skewness. I'm just going to help you understand what exactly the information skewness interprets and what we interpret from that and what we conclude from skewness. Right? There's a formula to calculate skewness, which I can show at the end, but that's not a necessity, or maybe that's not a super important thing to understand or to remember. But yeah, understanding the essence of skewness, what exactly set of information does it represent, that is important. So let's go and talk about it. Now the answer to the question. Here we go. So we're going to be understanding skewness. Let's take an example here. So let's say we have information about the marks obtained by students in a math exam, right? So we have data of marks obtained by students in a math exam, and we have number of students. Okay? So for each student we have marks obtained, and we are trying a graph between the number of students versus marks obtained by students. Right? Now let's say if the exam was super easy, exam was very easy, then can you say that the majority of the students in the math exam will get high marks? And all of you agree to that? That if the exam was super easy, majority of the students are going to get high marks. Right? And in that case, the distribution of marks is going to look like this. The distribution of marks is going to look like this. If I have to draw it a very smooth curve, it might look like this, right? Where, as you can see that at a higher, at a higher marks, you can think of this as, let's say, this is showing like 100, this is like 90, this is like 20, this is 30, right? So these are the marks. So you can say that at a higher marks, there are very high number of students. Right? The number of students are higher. Okay, so that's what interpretation you can see here, right? And so the exam was super easy. Majority of the students put high marks, right? So everyone is happy about that. But then there were a few exceptional cases like me who got lower marks even in the easy exam, as you can see here, right? There are a few exceptional cases like me who got even low marks. Yeah? These are the people who got low marks even in easy exam. Sorry, yeah, even in very easy exam. So that's where, right? That's where these are the people who are, you can say, these are the people who are more of exceptional cases, or you can say outliers, right? Now, because of presence of these people who got low marks, even the exam was super easy, right? Everybody got high marks, but these are 2-3 students who got low marks. Because of this, the distribution of data becomes skewed, right? So what do you mean by that? Let's understand. So when you look at this statistic here, I mean this distribution here, the highest peak represents the highest peak here. This peak represents that this particular marks, right, which is like this marks, was obtained by maximum number of students, right? So because y-axis is representing number of students, that means this marks, which could be let's say 85 or 80, was scored by maximum number of students. So always the highest peak, the corresponding x-axis is more of the data, right? Always in any distribution, highest peak is more, which is the marks obtained by maximum number of students, right? The central value is always, in any data distribution, the central value is always the median, because if you arrange your data in ascending or descending order, the central value will not change, which could be let's say 50 or 55 marks somewhere around, right? And that's the median of the data. Right? The central value is median. The central value in the x-axis is the median of data. Now, everybody got good marks, exam was super easy, but there are few outliers who got low marks. Because of these exceptional cases, the mean of the data shifts down. Because of these exceptional cases, the mean of the data shifts down. And that becomes a challenge in the data, right? So that becomes a specific challenge in the data, right? So because of these low scorers, the mean of data goes even down, and the mean somewhere comes to here. You know, so this because of this, you can say that this slant is observed, right? This slant is observed. This slant is observed, and this slant, or you can say this particular slant, right? So this slant is called as skewness, right? So this is geometrical meaning of skewness, and mathematical meaning is the mean shifts from median either below or above. That's called skewness. Here the mean is shifting below median. It is less than median if you look at the marks. Right? So we call this data as left skewed, or this distribution as left skewed or negative skewed. Right? So we call this distribution as left skewed distribution or negative skewed distribution. Right. So because of few outliers, the mean shifts down. Right? So if I have to show you a practical example of this, it could be, let's say, right. So let's say that there are marks which is like 20. The marks scored by students are like 95 plus 98 plus 96 plus 99 plus 92 plus 93 plus 94 plus 91. These are the marks obtained by students, right? But then there are few low scorers like 22, 21, 23. Now because of these low scorers, what will happen? You know, if I look at some of the values, it's 1017. If I count them up, 1, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13. I'm going to add one more, right, which is let's say 20, right. Okay. So this is the marks of 14 students, you can see, right. So if I look at the mean, so you can say mean is going to be the sum of all values divided by the count, which is like 14, that is 74. The mean turns out to 74. If you look at the median of the same data, so for median I have to arrange the data in ascending order or descending order. If I arrange that in ascending order, it becomes 20 is the lowest, 21, 22, 23. Right? So this is the way I am arranging the data in ascending order to calculate median. And then it comes 92, 93, 94. Oh, I missed 91. 1, 3, 4, 5, 6, 7, 8. Right. And so 94 is there, 95, 95, 10, 96, 98, 98, right, which is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and this 99, right? So if this is the data, if I look at the median of this data, there are 14 values, so the median is going to be 14 plus 1, which is like, 14th value and the 15th value, the mean of them, right? So you can say that. 14 by 2 is 7, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 value is this. So median is going to be the mean of these two, average of these two. So that's going to be, you can say, 93.5. That's the median of data. So in this case, can we say that mean has shifted below the median because of few exceptional cases, right? Because of these exceptional cases, majority of the students got high marks, but there are few students who got low marks, right? So these are the exceptional cases. Because of these exceptional cases, the mean has shifted down. It is only 74, whereas median is 90. Right. So in out of mean and median, which is good representative of data in this case? Majority of the data are closer to mean, or majority of the data are closer to median? What do you think, everyone? Is it that majority of data is closer to mean, or majority of the data is more closer to median? What is good representative of data? So I hope all of you agree that in this case, median is a good representative of data. Majority of the data points are closer to median, right? So whenever data is skewed, that means there are few outliers or maybe some few exceptional cases. Because of those, the mean shifts either left or right, and mean is no more a good representative. Mean becomes biased, right? So that's where median becomes a better representative of data. Right. So in this case, you can see that majority of the data points, which are like this, majority of these data points are more closer to median compared to mean. Right. So majority of the data points, which is like this, majority of the data points are more closer to median compared to mean. Okay, so that's one of the situation. So we call it left skewed or negative skewed. In this case, if you calculate the value of skewness, it will be negative value, or it will be it will be always a negative value. Similarly, in another situation, if let's say the exam was super easy, it was not difficult, rather it was super easy. Exam was very easy to get, right? Sorry, the earlier was easy, right? So this was easy, and let's say another situation, exam was difficult. Right. So if exam was very difficult, majority of the students will get low marks. So the data distribution will look like this. Exam was super difficult, majority of the students got low marks, but then there are few exceptional cases, like many of you who got high marks even in difficult exam. Right. And these exceptional cases make the mean shift higher. So the highest peak, right? So x-axis still represents marks, and this represents the number of students. Right. So highest peak is still the mode, right? So you can say that this is the mode. Central value is median. Right, central value is median. But when, because of these few exceptional cases who got high marks even in difficult exam, mean shifts higher. Right. So mean is above median. So we call it right skewed or positively skewed. Right. Right skewed or positively skewed. This line is skewed, skewness you can say. In this case, majority of the data points, is it more closer to median or mean? So in this case also, it is skewed, right? So is it more closer to median or mean? What is good representative of data? So I hope all of you agree that in this case also it is median to which it is more closer to, and median is good representative of data. So whether the data is positively skewed or negatively skewed, median is good representative. right? Now, third case, where it is not skewed. The exam was neither more difficult, it was no easier. It was a normal exam. So x-axis shows marks and y-axis shows number of students. If the exam was neither difficult nor easy, the data distribution would look like this. And in this distribution, the highest peak, the highest peak, as we already know that, it represents the mode. As the highest peak is occurring in central part of the distribution, that is also closer to the median, and that will also become closer to the mean as well. Right? So in ideal normal distribution, they will be equal to each other, but in general normal distribution, they will be closer to each other. In this case, we call this distribution as normal distribution. And here the skewness becomes almost closer to 0. Right? So we call it normal distribution. In this case, we consider that mean is a little bit representative of data because mean, median, mode are 3 closer to each other. So we still give more importance to mean. Because calculation of mean incorporates all the values, whereas median is just a single value of the large point of data. So we give more preference to mean in this case, and you can say mean and it is 0 skewness or normal distribution. So I hope this makes sense about the idea of skewness, what exactly is skewness, and how does skewness answer the question, what is good representative data, median, or mode? Or in general, how we use skewness in practice. So are we good with that? Right. So if we have missing values, and if we want to fill the missing values by mean or median or mode, we should look at, if it is numeric attribute, you should look at skewness, and if it is closer to 0 skewness, you should fill it by mean. If it is very negative or very positive, you should fill it by median. Right? So that's how skewness helps in general, and that's how that's the meaning of skewness in general. This is a formula to calculate skewness, which is like which is median minus mean upon standard deviation, right? So that's the standard formula to calculate skewness. But you don't have to remember that. You have to remember what the meaning of skewness. What do you interpret from the value of skewness? If the value of skewness is negative, it's the first condition, and it's positive, it's the second condition, it's closer to 0 to the third condition. Right. So if it's if these are the 3 situations, let me ask you a question. Situation 1, situation 2, and situation 3. If it is stock market data, let's say that these are the 3 distributions of return on 3 stocks, stock A, stock B, and stock C. This is representing return of stock A, this is representing return of distribution of return of stock B, and this is representing distribution of return of investment on stock C. So which of the stock is more profitable? Which stock you want to invest into? A, B, or C? Which is the most profitable stock and which is the most risky stock?
Kai, gitu tam.
Right. So if these are the 3 distributions of return of investment done on the stock A, stock B, and stock C, so which is the most profitable stock according to you? Right. So I hope all of you agree that stock A is the most profitable one because majority of the return is higher, is above mean. You can see it is above median. Majority of the stock, majority of the investors got the return higher than median. Right. Whereas in stock B, majority of the investors got return lower than mean. In stock C, 50% of them got higher than mean and 50% of them got lower than mean. So skewness is negative. If negatively skewed data that we have, that shows a good stock, right? That shows skewness can also be used to assess the quality of stock based on the value of skewness on the return gain from the stock, right? But the idea of skewness is clear, right? Let me know if you put that. I think 6 more. Have you all put in any question you have? Okay, so let's move further, and we are now shifting to the back. Yep. So so we can see that skewness of skewness of temperature is very much closer to zero, between like minus 0.1 to plus 0.1, so we call it normal distribution. Whereas pressure, which is like more than plus 0.1, so it's kind of positive. So let's fill in the missing values over here. So we can say that df dot temperature dot fill NA df dot temperature dot mean, that means we're going to fill the missing values by mean, and we're going to say in place equals true to completely include it, right, within the same data frame. And pressure, so pressure dot fill NA df dot pressure dot let's say we're going to do that by median, and in place equals true, right? And now if you look at df dot is null dot sum, now if you check the missing values, so well we have errors. So data frame has temperature index. So now you can see that we have filled the missing values and not having missing value available. So we have filled the missing values in temperature by mean and pressure by median, and we have no missing values in both. So we will clear what any question you have, And third, we look at the idea of outliers. How do we handle outliers? There are multiple ways to identify outliers, right? But yeah, so how do we handle them now? We are looking at that as well. Even if you look at this part, so any question you have this. Have you all put in one? We will move further to look at the idea of outlier. Have you all put here? So in place synthetic is to make the changes in the same data frame. So let's say that if you are filling the missing values, one of the situations could be you may not want to make the changes in the same data frame here. Rather, you want to keep it as it is, and you want to simply create a new data frame in which there is not be missing value. So in place true if you want to make changes in the same data frame, in place false if you don't want to make changes in the same df. You have to create a new df which could be df2, which doesn't have missing value. Are we good with that? Okay. So well, let's move further, right? Let's move further. So this is now we will talk about the idea of how to handle outliers. So how do we identify outliers? Well, there are multiple statistical methods. One of the simplest methods I'm showing is like with students. Well, that's one of the practice, right? So the method is like if skewness is greater than +1, or if skewness is less than -1, then that means yes, outlier. Right. If you look at df dot skewness, so outliers are exceptional cases. The meaning of outliers is an exceptional case. So let's say that all the machines are operating on temperature of 80 to 100 degrees Celsius. There is one machine which is operating on temperature of maybe 500 degrees Celsius. So that's an outlier. Outliers are natural cases, but they are exceptional. let's say that in a class there are students having age between 10 years to 13 years, but there is one student who is having age of 55 years. Now that is naturally possible. There could be a student of 55 years age, right? But they are outliers. They are exceptional cases, right? So outliers are natural, but they are exceptional cases. In some cases, the outliers might occur because of the instrumentation error, because they are not really outliers, but there might be some instrumentation error. They are unnatural values. For example, let's say if the value of age is 500 years, naturally it is not possible, right? These are also unnatural situations of having outliers. In some cases, it is natural, right? Which is technically possible, but in business context, based on business context, it is really different case. So that's an idea. So we have to deal with them. We have to handle them. Either you want to drop that particular rule, or else you want to possibly impute that outlier with median mode or stuff like that. So I hope that answers the question about the idea of what are outliers. Right. They are exceptional cases, but present in the data. Right. Okay, so that's an idea. So as you can, how to identify that if there are some exceptional cases, very exceptional cases, so look at experience. Experience is greater than +1 or less than -1, that is based on. If it is greater than +1, that means there is a very high value of that. Let's say that most of the customers in the bank are having age between 20 to 60 years, but there is one customer having age 92. Right? That's a high level. On the positive side, and on the negative side, it will be most of the customers having age between 20 to 60, but there is one customer having age as 21 years. Right? That's negative side of that. Or lower side of that. So negative experience less than -1, that means lower side of that, more than +1, that means higher side of that. We can see that moisture has an outlier, right? As we can see that moisture has an outlier present, and that's where really the moisture have an outlier. If you look at total number of values here, right? So one of the way to explore outliers, like if you look at total number of values here, units, right? D of dot shape. So we have total 1,007 columns. 1,000 rows and 7 columns here. And so if you want to explore the outlier of moisture, one of the way to see that is you can draw a scatter plot. So I can simply do the dot moisture plot right equals equals scatter. Maybe we can simply draw a scatter plot saying here the dot scatter, here the scatter. On the x-axis we can say d of the dot index, on y-axis moisture.
You have used D of this.
Yeah. So here we go, and this is our data, right? So if you look at this scatter plot of the data, there is also one of the very popular plot which is like box plot. That also gives you a clear understanding of the outlier. If you look at this, so you see we have some data of all the machines, right? So if I try to increase the size of the plot, interpretable more. It is the width and 5 is height. Instead of height on let's say 10 as height. So you see here, these are multiple dots. Every dot is one machine, and so every dot is one machine, and there are 1,000 dots on this graph. As you can see that most of the values are having moisture. So we are looking at the data of moisture. Moisture less than 200. You can see that most of the things are like moisture value less than 200. But there is one dot which is actually crossing 1,000, and that's an exceptional case. That's an exception. There is one such dot. Yeah, there is one such dot which is exceeding the value of 1,000. Looks like it's lower than 1,200. But typically, when I looked at this statistical distribution, it was like 300 somewhere. But yeah, so you can see that there is one value which is exceptional, right? So this value is exceptional case, and that's an outlier. You can see it's very different from the majority of the data points. And in that case, maybe you want to drop that. So in such situation, you can see that you can directly take an action. Well, let's drop all the values of moisture which are having value higher than 1,000 or maybe 500 or maybe 400. You can take a threshold and higher than that threshold you can look about dropping. That's one way. Another way is to use box drop method like 1.5 times IQR. Higher than that, you want to drop it. Another method is you can use Z score as well to drop the outlier. There are such multiple methods too, or approach to drop outliers. One of the methods we can look at is simply all the values more than 1,000 and drop it, and that's how we can drop this particular outlier, this particular machine's data. So to drop that, let's drop the row of the row which contains the outlier. So we can say that df equals df where df dot moisture is less than 1,000. So that's what we said here. Now if you look at df dot shape after dropping that, let's see how many we have dropped. So well, from 1,000 we now got it reduced to 999. That means we have just dropped one row. And now if you look at df dot skewness, we can see that from 15 we have reduced it to 1.5, which is quite good. Still, it may have few outliers. You can see that values are a little higher at the moment. It's more than +1. Still, it may have few outliers, but still, this is something workable. It's not really very higher than +1. Earlier it was 15, as you can see that 15.9, right, which is like very higher than +1. Right, so that's how we have dropped the outlier, and now the data would look quite simple and you can see easy to integrate as well. So this is where we have handled the data part, and now we can say that we have almost a clean data to proceed further. Right. So I hope we're going to this part, everyone. Right? We're going to proceed further. So this is where we're done with step number 3, and now we move to step number 4, which is where we're going to be working with exploratory data analytics, right? And this is where we're going to use the visualization to handle the situation. Right? I mean, to perform data analysis, right? So this is the main part which we want to actually come up with. Any question you would have to hear. So now we're going to shift into the most interesting segment of this particular workshop, right? The most important segment, I would say, which is where we're going to be exploring about what's happening in the data and what exactly data says and why it's happening, right? So why machines got damaged. That's the part which is going to come up. Yeah. So there are 3 main components of data cleaning. There are even a few more. So which include you have to handle duplicate entries, handle missing value, handle the outliers. These are the 3 main components of it. Right. They could be even more. You may want to drop the unnecessary or not important values, right? Or you may want to drop the columns which all have same values, right? There is no other category. You may want to deal with unnatural values as well. This could be very other, but these are the 3 popular issues or quality challenges, the cleaning challenges that we're going to do. Right? So we checked for duplicates. We didn't have any duplicates. We had missing values. We cleaned them. We had outliers one of the every column. We cleaned that as well. Right? So we follow this template. And make sure that we remember that we follow this template, and that's where we are. Now is to exploit data analytics. That's the this question, there's still a skewness of moisture is, it's more than +1. So for the outlier sign, it should be less than -1 or +1, right? So you can see that we have written the rule here. If it is more than +1 or less than -1, then it is challenged rather than it is outlier. And we can see that it is not, it is still higher than +1. It is higher than +1. So it is not 0.1. We look at +1, right? For outlier part. So it is still higher than +1, so you can still have outliers in this, right? But that's closer to 1, so we can say at this moment we can negotiate with it and we can proceed further. It's again our call. We can still drag a little bit deeper, drop a few more values to decrease the for a few more rows to decrease the skewness and make it workable. Right? But in this case, you see the volume of data is not very large, which is like only 1,000 entries that you have, so you may not want to lose more data. Right? So you have to answer the question. And the true range which is to have skewness between +1 to -1. Right? For not calling it outlier. Right. So that's that's an idea so far. I hope we're good, right? I think we have wasted time as well for the day, right? And so we will not be able to complete this fourth step today, right? So we will kind of keeping this for tomorrow's session in that case, right? So we have the session tomorrow as well, as you already know about that, right? So at the moment, then we'll take a we will declare a follow-up for the day, and we'll resume this further tomorrow. And we'll work on top of this tomorrow, right? So I'll try to share this in the notebook, right? So we'll check it out, right? So I'll you just drop it in email to the same email, and I'll ask the team to share it. So thank you all for joining the session in that case, and today now we'll call off the session. We'll meet back tomorrow and continue this part. Yeah, the fourth step is going to take a lot of time. We're going to learn a few more